Hello guys, good evening. Yeah, I'm Murthy from L&D Technology Services. I'm a Comcast assignee for Linaro. So we're gonna see this session how RDK media stack with version 3.0 we are porting to IMX8 64-bit board, yeah, and content decryption playback with Playready DRM. So we're gonna see a brief introduction about RDK and 3.0 features and the efforts we made on making 64-bit compatibility to RDK on video profiles, and what are all the supports we added for making RDK support on that build system. So, and these changes how we are upstreaming to RDK community, and secure decryption with Opti on WPEWebit and framework using EME3.0 on Thunder framework. Yeah. So these are all we're going to see in the session. Yeah. So introduction about RDK. So it's a complete, fully integrated media stack. And it's a software solution for connected homes. This is open source for RDK community. So this provides a common framework for powering CPE devices such as set-top boxes and residential gateways. So this has a standardization for core functions for video, broadband, camera, and IoT devices. So RDK is a media stack, and it can be used over any operator. So it is a modular media stack. So it can be placed on any devices, and any operators can be place their applications over this RDK. Yeah. So. So this provides a set of documentation, and it has software components and tools so that we can go for a faster development. And this RDK stack is based on standard Linux. So it uses open source components from Open Embedded Core. Yeah. So it has a wiki page, as mentioned in the link. So let's see RDK evaluation. So from the base version, it has media framework. It's specific to RDK, so it's based on GStreamer, and it has a VLAN compositor called Westeros. Westeros is a lightweight VLAN compositor, and it can be capable to run as a standalone or nested composition and embedded composition. So it's developed by Comcast. So this RDK media stack is specified by Comcast, and this has different profiles for video gateways. So on the version 2 base, with the base version, they have introduced TR69 for diagnostics. So it uses remote management. So TR69 host interface and HDMI CEC storage manager, and it uses Qt base for windowing framework and Qt WebKit for browser experience. So on RDK 3.0, to overcome Qt, they have introduced another framework is based on JavaScript, that is Spark framework, and they have a media player for HTTP live streaming. And for overcoming Qt WebKit, they have used WPEWebit, and they have developed one simple application that instantiates WebKit browser. So that we call RDK browser 2. So let's see 3.0 features. So as I said, Spark framework. So this is a cross-platform framework. This will give a windowing framework, and it has 2D scene graph that exposes to JS engine. So in architecture, it has a core element that implements JavaScript interface and native windowing interfaces. So this native windowing interfaces is cross-platform environment. So currently supports on Linux, Mac OS, and Windows. So it's open source. Over the core element, it has a framework, and the framework is the application engine. It contains JS bindings, which has the text boxes and other GUI elements. And also it handles 2D scene graph. So overall, this with the framework and the core element completely, we say it as PX scene. As I said earlier, Westeros is a Wayland compositor. So ESOS is also another compositor that is the companion to Westeros. So compared to Westeros, ESOS is lightweight more than that. And it creates Wayland display and creates application that can be capable to run either as a native EGL or Wayland clients. So overall, the Spark framework is the replacement for Qt-based windowing framework, which was used in RDK 2.0. So this framework will give you a environment for application in JavaScript. So this will give you asynchronous behavior, and it can download JS code and runs in the client boxes rather than going for several reaching server many times. So it can run as a JavaScript in the native environment. So another one is AMP player. So that is it's a simple application for supporting IP playback. So this is a player is based on GStreamer, and it supports Apple HLS and MPEG- streams. And also it supports HTML5 video tag support on WPE, and it also has HLS parser and DRM manager. So it supports Playready and Widevine also. And it has a GStreamer plugin over that uses the AMP application. So as I said earlier, RDK browser based on WP is a simple application that gives a browser environment that instantiate WP WebKit. Yeah. So on 64-bit, currently RDK available on all 32-bit ARM platforms. So RDK components are currently available in 32-bit support. So when porting that to IMX8, Freescale provides 64-bit EGL library on open source. So on making RDK on Freescale board, so we added a compatibility for 64-bit. So also for Thud migration, Freescale provides Yocto meta layer in Thud version. So currently RDK maintains Yocto build system that supports on Daisy and Marty versions. So on with the Freescale meta layer, so we have added that support on meta layers of RDK. So these are this is the overall architecture of RDK. So the media stack contains GStreamer media framework. Over that, it implements media framework for RDK that has several source and sync components for QAM and IP and DVR. So that is the media framework is the major one, and it has device settings, service manager, and basically it has a internal bus called IAM bus. It's based on DBus. It's abstraction layer for DBus, and it has IAM manager to control the elements, and through this bus all other RDK components interact with each other. So coming to open source side for graphics and browser experience, it uses Westeros compositor and it uses Thunder framework from Meteorological, and it uses WebKit and other open source components, systemd, busybox, everything from OE layer. So as I said, it's a modular thing, so we can have either as a the base layer will be SOC layer or OEM layer that can be provides the SDK or OpenGL, Linux kernel, everything from those layers. So over that we can have the MSOs on top of RDK. So these are all the challenges we faced in making compatible for 64-bit on RDK components. So device settings and few components from RDK Media Framework uses 32-bit handles. So internally they maintains device handles in 32-bit format. So all those are made to 64-bit compatibility. And PX Core and PX Scene is nothing but the Spark framework, and there ARM64 machine support was added. So RT remote is nothing but the RDK implemented RPC module. So it uses function as objects, and it may basically with client server mechanism and uses for RPC between RDK modules. So these are all the efforts we made, and for media framework side, we have added ARC64 support. So based on the handles implemented is defined based on the pre-processing macros. And IAM side, we have used so the pointers for size-t are made compatible for IAM manager side. So these are all the changes related to 64-bit compatibility made on RDK components. So coming to RDK build system, it uses Yocto project build system, and it currently supports on Daisy, Krogoth, and Morty versions. It uses open source components from open embedded Yocto layer. Mainly it uses busybox, systemd services, curl, GUP, NP modules. So mainly RDK restricts general purpose licensing with version 3+. So those components will be blacklisted by RDK. So so for using that components, it will be taken from Meta GPL v2 layer. So RDK maintains different Yocto layers to have their distros in separate layer, and basic components, everything will be in Meta RDK layer. And it for video profiles and broadband profiles, they maintain different layers. So there you find Meta RDK video contains some components which are used under for video profiles. For open embedded core components, enhancements on RDK will be maintained in separate layer. So completely for open community, they have introduced CMF layers for all these available RDK layers. So it has BB appends, and it points to the open source repositories. So this is the so on Thud migration to RDK layers. So this is the approach we used. RDK meta layers are generic one. So to making that compatibility, we need to switch the open embedded core and meta open embedded layers to that branch. And Meta Freescale will provide the SDK, and it takes the master branch. For WPEFramework and WebKit side, we have taken Meta WPE master branch. So that provides Westeros. So even though the Westeros is specified by RDK, Meta WPE maintains a separate version. So that is because WPEFramework and WebKit is based on Westeros. They have maintaining one separate version from their side. So on bringing up WPEFramework and everything to with RDK, so we use Westeros from Meta WP layer. And on porting RDK on any specific SOC, so we need to introduce a new layer, which is in case of Freescale, we have added Meta CMF Freescale. So that layer contains specifically to RDK changes, which is applicable for the particular SOC. From the third version, we have switched to so the latest versions to the open embedded components. So these are all the open embedded components which are from third version on RDK porting. So some of the components will be to be fixed to a particular version that is compatible, means dependency with the RDK. We need to OpenSSL will be 1.0 version. So even though open embedded core layer provides 1.1, RDK expects for 1.0 because of the dependency, and GNU TLS also will be with 3.3 version. So these are all the challenges we faced on migrating to Thud. So very first, we need to check the compatibility and dependency of for the open source components that are using with RDK components. So as we seen earlier, some of the versions from Thud we can use used for RDK media stack, and some to be maintained with the particular versions. So that will be maintained in a separate RDK layer. So that should be taken care. Later, a Meta RDK extension layer that is for having the enhancement for open source components. So those have some specific patches for applied for RDK enhancements that has to be repatching for newer versions. And open embedded core with that version that gives a toolchain GCC 8.2 version. So when building the RDK media stack with GCC 8.2, so there are a lot of warnings and errors. So that are all fixed here. So when porting RDK media player for HLS streaming on building with GCC 8.2, we have faced some issues. So some of optimization flags we need to disable. So on GCC 8.2, alignment of loops and jumps are newly introduced. So that make the particular component making to infinite looping and leads to a memory crash. So these flags has been removed on build with GCC 8.2. And some of the Thud migration changes are mostly on recipe sides. So in order to overcome the sysroot dependency, so in latest Yocto system, it generates sysroots on a particular component folder rather than in a common directory. So some more dependency we need to add. So those were added. Yeah, so RDK Media Framework, as I said, this is the major part of the media stack. So this will be based on the GStreamer media framework. So it implements some source and sync and filter elements. It's abstraction of the general one. For RDK, it implements DVR, QAM, and HTTP sources and syncs. So coming to media client side, the framework implements a media player sync. So that player sync is the simple GStreamer based plugin. It's based on GST bin, and it's instantiate SOC specific decoders and syncs. So internally it forms a pipeline. So in case for Freescale MX8, so this is implemented in the way it instantiate TS demixer, and it forms a video pipeline with the SOC specific video decoder and the audio decoder, and this will be the player sync bin used in media framework. As RDK media framework uses mostly on MPEG transport streams, so TS demixer will be chosen. So from the data streaming from the media server that gives to the HN source. So the HN source will be in the client side. So it accepts the data, and the player sync will be capable to creates the video and audio pipeline and make the video playback. Yeah. This player sync bin implementation is for NXP IMX8 board is implemented for this porting. So those are all the overall changes we made for the 64-bit and Thud compatibility, also for media framework. So those implementation were upstreaming to RDK community. Also Comcast maintains their own Gerrit repositories. So very beginning we have proposed all the changes to the Comcast Gerrits, so that it will be internally reviewed, and this can be integrated quickly to the repositories. So very first we have created a future branch on all those components, and we proposed all the changes. So currently now build and regression testing is going on with RDK existing devices. So once that is evaluated, all these changes will be moved to the stable branch, means from the featured branch to the stable branch. So later, once that it merged to the changes were merged to stable branch, so automatically it lands on the RDK CMF community. So this is how we are upstreaming all the changes which are made for 64-bit compatibility and Thud compatibility. And we have documented the efforts we made for porting 64-bit RDK and Thud migration. We have documented in RDK wiki, and we have a build procedure, and we maintain a manifest to have open embedded core Thud version and other meta freescale layer and meta WP, everything we have manifested in. And we prepared a build procedure for Yocto build system. So these links will provide you the efforts made on 64-bit, and we can go for a procedure to go for a build. So these are all the other contributions made for made from Linaro. So under Westeros side, Westeros compositor, we have made Westeros is also supports direct rendering manager. So on that side, we have added dynamic mode selection based on the native Windows side, and EGLC flags we have introduced. We have added some commits we have made on Westeros, and dynamic mode selection they have written as a runtime module that we enabled. And for WPE side, we have contributed on WPE backend and the WebKit side. And for Playready content decryption, so there is a CDMI implementation on WPE side. So there a contribution we made from Linaro. Okay, so these are all the total efforts and work made for 64-bit compatibility and the Thud migration on RDK media stack. So coming to secure decryption playback, so we have used Thunder framework from Metrological. So that is the open source simple framework for embedded device browser experience. So this is a plugin based framework. So all utilities will be loaded as a plugin, and it has inter-plugin dependencies. Framework, so the architecture wise, it has a core element. The framework has a core element, the core element that implements Web API, RPC, and it has a controller to load and unload plugins. And it has a JSON parser and WebSocket APIs capabilities. Along with the core element, it has various plugins implemented for WebKit browser, and it has a compositor plugin implementation, and it has a network controller. The compositor mainly uses Westeros compositor, which is developed from the RDK. WP also uses Westeros compositor on their backends. So coming to the framework UI, so These plugins also can be very beginning. So these plugins can be configured through JSON files. Over that, from the UI, it has a web-based user interface to control the framework and the plugins remotely. It works on port 80 and it opens the web server and interacts with the plugins. So these are all the major components in the Thunder framework. This is the architecture how secure decryption will be happened on WPEWebKit with encrypted media extension 3.0 version. So Thunder framework loads each plugins. Very first composer it loads for graphics, and it loads the WebKit. WebKit has media source extension implementation and encrypted media extension 3.0 implementation, and it has a GStreamer pipeline internally for video playback. And it has OpenCDM implementation along with the WebKit. And separately, Thunder framework implements OpenCDM server that can be interact with the Oh, okay. Yeah, I'll make it soon. Yeah. It implements shared buffer. So through the shared buffer, the encrypted content and the clear content will be shared between the WebKit and the OCDM server. And it has a CDMI implementation for different key systems that can be interact directly to the OPT. Currently, we evaluated Playready on EME3.0. A contribution we made from Linaro. So this is the overall the flow on the Thunder framework for secure decryption. The decryption will be happen in the OPT side, and these are all the components involved in the Thunder framework. Yeah, that's it. So currently we are working on RDK upstreaming and Widevine integration with Thunder framework. So we evaluated Playready on that. So currently Widevine integration is going on. So future activity will be secure data path integration for fully secure video playback. Currently the decryption is happening in the secure side. So for fully integration, fully secure video playback, so we need to integrate that, and the contribution toward RDK camera profiles use cases, we are working on it. And later RDK introduces another version, so it goes for 4.0, and we can the future activities we have proposed for having RDK 4.0 with Yocto 2.7 support. Yeah, that's it.